Okay, so today we are starting the periodic table. As you can see the topic here, periodic table. Alright, so we are just going to discuss about the first group for today. Alright, so let me zoom it out. So as you can see here, the groups are always the columns and the periods are always the rows. Alright, so what are groups? These are like verticals and these are columns always. So let me write here. Groups are always what? These are columns. And columns are in what? These are verticals. Alright, columns, and these are always vertical. Alright, as you can see here, groups are always columns and columns are always vertical. Now let me talk about the periods. Alright, periods are always in the rows. Alright, so I can write here as well. Periods are always rows. And rows are always what? These are horizontal. Horizontal. Alright. So groups are always columns and columns are always vertical and periods are always rows and rows are always horizontal. Alright, so we are just going to discuss about the groups which are always columns and are in vertical, as you can see here, which I've highlighted with pink pointer. Alright, so let me change the color here. As you can see here, the first element we have, which is hydrogen, and the hydrogen place and helium place is not decided yet. Like these are placed where we don't know, but these are placed on the first group, and helium is present on the not in the second but eighth group. These are noble cases. Alright, so their places are not decided yet. So from lithium to francium, these are always first group, but hydrogen we are taking as well. Alright, so hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Alright, these are always in the first group. And what's the characteristic of first group? Like except the hydrogen, these all are alkaline metals. Alright, so let me write here with another color. I should go with this color, white. Alright, so lithium, we have lithium, we have sodium, which is represented by Na. Then we have potassium, which is represented with K. Then we have rubidium, which is represented with Rb, capital R and small b. Then we have cesium, which is represented with capital C and small s. Then the last we have francium, which is represented with capital F, and we have R, small r. Alright, so these all elements are what? These are alkaline metals. So let me write here. These are what? These are alkaline metals. Alkaline metals. Now, what are the characteristics of these alkaline metals? Alright, so alkaline metals are like dissolvable in the water as well as in the air as well. These are what? These are dissolvable in the water as well as in the air as well. So they are always kept as close. Alright, if they will be placed openly, so it will be dissolved in the water as well as in the air. It will react with the water as well as in the air as well. So that's why they are always put closely. Alright, so now let me tell tell you the representation. Like, let me tell you the symbols first. Okay, so let me use this color now. We are going with the symbols of first group elements. First group's elements. Alright, so now we are going with the samples of the first group's element. So first we have that is hydrogen. Alright, let me change the color. I should go with this color now. This would be light then. White is fine. Okay, so first one we have that is hydrogen. Hydrogen, which is always represented by H, only H. Alright, so second we have that is what? That is lithium. Lithium, which is always represented with capital L plus small I. Alright, this is lithium. Third we have what? That is sodium. Sodium, which is represented with Na, capital N and small a. Alright, last, not last, but we have fourth one, which is potassium. Potassium, which is represented with capital K. Capital K. Alright, fifth we have rubidium. Rubidium, which is represented with capital R and small b. Capital R and small b. Alright, so sixth we have that is cesium, which is represented with what? Capital C and small s. Last but not the least, we have francium. Francium. Francium, which is represented with capital F and small r. Alright, so these are the samples of the first group elements. Alright, so now how many electrons are present in their outermost shell, or how many electrons they are losing. Alright, so we need to know that if they are present in the first group, I should tell you the periods as well. So we have, as you can see here, we have total here 7 periods. Alright, we have 7 periods and we have 18 groups. Alright, so now we should go with the valence electrons. If I am going with the valence, not with the valence but the structure of sodium. Alright, so I am going with the structure of sodium here. Should go with this color. Sodium structure. So here I am going to make the sodium structure. Let me change the color. Okay, so here we have the nucleus, and we know that in nucleus what are present? In nucleus we have the proton and neutron, and proton carries the positive charge and neutron carries no any charge. So I am representing it with the naught. Alright, and electrons are present what? These are present in the shells. Alright, these are present in the shells. Now how many shells are present in the sodium structure? We need to know that as well. So in the sodium structure we have 3 shells. Why these are 3 shells? Because sodium is what? Like hydrogen is in first period. Then periods are representing what? Periods are representing the shells. If hydrogen is in the first period, then it means hydrogen has only one shell. Lithium is in the second period, as you can see here. Lithium is in the second period, so it has 2 shells. Then again sodium is in third period. So it has 3 shells. Alright, so that's why I have made here 3 shells. So now we have to go with the electronic configuration as well. Alright, so in the first shell we have always 2 electrons, 2 electrons. Alright, in the second shell we have 8 electrons, and in the third shells, if you have 18 electrons, then you can put in the third shell 18 electrons, or if you have 8 electrons you can put 8 electrons as well. But if you don't have 8 electrons, like here the sodium's atomic number is what? It is 11. Alright, so 2 is in the first shell, 8 is in the second shell, 2 and 8, 10. Only 1 electron is left. So 1 electron will be there in the valence shell. So again, what it will do, either it is to complete its duplet rule or octet rule. So it will lose this electron and it will give to an other, which will make the bond with it. Alright, so it will always carry the positive charge. So not only sodium, but always, like the elements which are present in the first group will always carry the positive charge with that, because in every element of the first group will have only 1 electron in its outermost shell. Then always it will lose its electron. It will make the bond with other element and it will always lose its electron. That's why they'll all carry the positive charge. Like hydrogen will be carrying positive charge, sodium will be carrying positive charge, lithium will be carrying positive charge, potassium will be carrying rubidium, cesium, and francium as well. So they all will be carrying positive charge just because they are losing their 1 electrons from the outermost shell. Alright, so now we need to know that what are the atomic numbers of these elements in the first group of the periodic table. Alright, so always hydrogen's atomic number is what? Wait, let me change the color of the marker. I should go with this color now. Alright, so always hydrogen has 1 atomic number, lithium has 3 atomic number, sodium has 11 atomic number, this is 11, potassium has 19, rubidium has 37, cesium has 55, while francium has 87. Now we need to learn this. Like hydrogen atomic number is 1, lithium's atomic number is 3, sodium's 11, potassium's 19, rubidium 37, cesium 55, and francium 87. Alright, so now these atomic numbers are how these atomic numbers are made. Let's see. We have the electronic configuration. So let me write it down. In first shell we have always 2, then in the second shell we have 8, in the third shell we have 8, in the fourth shell we have 18, in the fifth shell we have 18, then we have 32. Alright, so now this is the electronic configuration. Let me write it down so that it can be more clear to you. This is what? This is electronic configuration. Configuration. Alright, so now if hydrogen's atomic number is 1, wait, let me write it down too. If hydrogen's atomic number is what? It is 1, then we have to add 2 with it. Like 2 will be added with it. 2 we have to plus, then we'll get 3. And 3 is the atomic number of what? It is the atomic number of lithium. Alright, again we have gotten 3. Now we have to add this. We have added this 2 with 1, that is 3. And 3 is the atomic number of lithium. Now we have to add 8 with this 3. So we have to add with 3. So it will give us 11. And 11 is the atomic number of sodium. Alright, sodium. Now we have gotten the sodium as well. Now we have 8. Alright, so now we have to add this 8 with 11 again. 8 with 11, what it will give us, it is erased. I'm sorry, we have to add 2 with it, so that it has given us 3, which was the atomic number of lithium. It is here. Then we got what? We added 8, because 2 we have already added, 8 we have already added. Then we added 8 with this 3. Then again we got 11, and 11 was the atomic number of what? Sodium. Alright, here we have sodium. Then again we have 18. Alright, so again we have to add in with this. Sorry, we have to add 8 with it, because we have added only 1 8 yet. So 1 8 we have to add with 11, so that it will give us 19. And 19 is the atomic number of what? It is the atomic number of potassium. So as you can see here, potassium. Alright, so now we have added 8 as well. Now we have to add this 18 to this 19. So 18 plus this 19, 8 and 9 give us 17, 1 on the up and 7 down, then 3. So 37 is the atomic number of what? It is the atomic number of rubidium, which is represented with capital R and small p. Rubidium. Alright, again we have added 118. Now we have to add the second 18. So 37 plus this 18. Alright, so 7 and 8 give us 15. So 5 down, 1 up, 3 and 1, 4 and 5. So 55 is the atomic number of cesium. And again now we have 32. So 32 we have to add with this 55. Alright, so 5 and 2 give us 7, and 5 and 3 give us 8. So 87 is the atomic number of francium. I hope how we have this is clear to you, that how we have made this atomic numbers. Alright, so we have just made this atomic number with the help of electronic configuration, which is 2, 8, 8, 18, 18 and 32. Alright, so how we need to learn these elements, like what elements are present in the first group. So we should go with a statement. So what that statement should be: हली ने की रब से फरियाद. ह hydrogen, li lithium, hali ne na means sodium, ne ki means potassium, rab means rubidium, ki which is done, ki rab se cesium, faryad which is francium. Alright, so this is the statement which we need to learn for learning the elements of the first group. Alright, so now this was all for today, as we have discussed about the first group's element. Tomorrow we'll be going with the second group elements. Alright.